lesson 2, properties of chords and circles. So we're continuing with our circle geometry. Start with what is a chord. A line segment that joins 2 points on a circle, that's a chord. So very simply, draw your circle, any 2 points, that is a chord. Important to know something like that is not a chord. Okay, it has to have the 2 endpoints on the edge of the circle. Very specific type of chord is the diameter. The diameter goes through the center of the circle, but it has its endpoints on the edge of the circle. So there's my diameter through the center. Okay, there's my diameter. The diameter also cuts the circle into 2 equal parts. That creates the semicircle as well. Okay, so those are chords. You probably just noticed them as being lines on edges of circles. Okay. Now, what is the chord property? I want to start by saying the chord properties, and it says that there are 3 of them. It's really one property with 3 parts. And if you are given any 2 of those 3 parts, then you have proven the 3rd. And that's how the chord properties are going to work. Okay? Here we go. Property number 1. We're looking for 3 important words here. The perpendicular from the center of a circle to a chord bisects the chord. Now, perpendicular. We know what perpendicular means. That's that 90-degree angle is formed. Okay, so we have a perpendicular from the center of the circle. Okay, so a perpendicular line that comes either through the center or originates at the center. And if you have those 2 things, you have a chord that is bisected. Bisect means cut in half. All right, so if you take a look at the example here, we have our center at O. Okay, so that's one part of the theorem. Center at O. We have a line that's perpendicular to the chord. That's OC. Okay, so that line is perpendicular to the chord, which then tells us that chord AB is bisected. We use these 2 little lines to show that AC equals, equals BC, like so. Okay, so AC equals BC. Okay, that's property number 1. All right, take a look at property number 2. The perpendicular bisector of a chord in a circle passes through the center of the circle. Okay, find our words. Perpendicular. Okay, so there's our perpendicular. Bisector. So there's our bisects, cut in half. So the perpendicular bisector of a chord in a circle will always pass through the center of the circle. So there's our 3rd. All right, here we go. We have QP, it's the chord. We see that the chord has been bisected by a line RS, and we know that that is perpendicular. Because we have a bisected line that is perpendicular, we then know that this has to be the center of the circle. It's pretty rare that we prove the center of the circle in any of the questions I've ever seen us do. It's usually center has been given and one of the other 2 properties. So here's the 3rd version. You might have to draw in this green circle. I'm not sure if you actually have a circle. If you do, then you can just add to it. A line that joins the center of a circle and the midpoint of a chord is perpendicular to the chord. So again, we're looking for those 3 important words. Center of the circle, midpoint. So midpoint is just another way we're going to say bisected. Midpoint means halfway, so it's a bisected chord. And here's that 3rd word again. Then we've proven something's perpendicular. So once again, we have a line through the center of the circle here. We have a chord. We should label it maybe. Let's call it AB. There's chord AB, and we see that it is bisected. We know that it is equal. Because we have proven a line through center and the chord, we then have proven that this is a 90-degree angle, and it's perpendicular. Now, what you can't see in any of these properties is the triangles. And so I want you to know that one of the best hints that I can give you for any of these problems is to draw a radius. So from the center of the circle to one of your endpoints, if you draw a radius, you then have drawn a 90-degree triangle. And that's my tip for all of these word problems. Create the right angle triangle. Okay? All right, let's, before we go on to the problems, I want to just summarize it. Instead of calling it chord properties with an S, it's really the chord property. And it has three parts, okay? We have part number one, a line through center. Okay, a line through center. Part two, we have a perpendicular line. Okay, perpendicular line. And part three, we have a bisected chord. Okay, so if you were to be given a diagram, and on that diagram you saw a line passing through center that bisected a chord, you have then proven it is perpendicular. That's how this property works. If you've got 2 out of 3, you've proven the third. Okay? All right, let's try a word problem. Okay, this first problem is actually pretty tough to start with. So why don't we do something just a little easier off to the side here, and then we'll get into this horizontal pipe here. So let's say I gave you a circle, and I'm going to give you chord AB. Just draw this into your notes. So I'm giving you chord AB. I'm giving you the line from center. We'll call that O. We'll call this little intersection point here C. Okay, O to C. And I want you to find the length of this place here. Actually, it's A to C that I want you to figure out. I'm going to tell you that the radius of this circle equals 10 centimeters, and that O to C in this circle is equal to 6 centimeters. Okay? So how could we find the length of A to C? So this is what I want to find the length of. Well, the first thing that I want you to point out is that this is a line through center, and this is a chord. I haven't told you if this is bisected or not. It is, with a little bisect mark in. It should be given like that. Therefore, I know this is perpendicular. Okay, so that's a 90-degree angle. Now, I also gave you the radius, but I didn't draw the radius. That's my tip, remember? Always draw your radius. We know the radius is 10. We know that O to C is 6. We're trying to find this piece down here. Okay? I have a triangle. 10, 6. What is that piece down there going to be? So we're going to go 10 squared minus 6 squared is x squared. We end up with 100 minus 36, that's going to be 64. And we know the square root of 64 is 8. So that missing side length is 8. Now, an extension question would be, how long is line segment AB? Okay, we can check this one step further. How long is line segment AB? Well, we know that AB has to be 16. Okay, why does it have to be 16? Well, if this is 8, then these two things are bisected. This is 8, so 8 plus 8 would be 16 units. Okay? Okay, let's try this pipe problem here. Horizontal pipe has a circular cross-section with center O, so we know this is the center of the circle. It has a radius of 20 centimeters, so you can just add that on. It's already in your diagram, just highlight it, O to A. So we know that O to A is 20 centimeters. Okay. Water fills less than 1/2 of the pipe. We know that the water is the blue there at the bottom, so there's a chord from A to B representing the top of the water. Okay, so we have chord AB. we know that that AB is 24 centimeters wide. Determine the maximum depth of the water, which is depth CD. So if you look at your diagram, CD is not very big. It's from here to there, okay? Now, a few things you need to know about the word depth. Depth is always measured straight up and down, and because it's always measured straight up and down, it's a 90-degree angle. So we have the 90-degree symbol drawn in there. Okay, so we know that that's a 90-degree angle. So if we're following our properties, we have a line through center. Okay, we have a line through center, check. We have a perpendicular line. Check, which means that AB is bisected. Okay, that means that AB is bisected, it is cut in half. So if AB is bisected, I then know that the measure of AC is going to be half of 24 centimeters, which would be 12 centimeters. Now, I'm finding CD. This is a two-step problem for me because CD is just sitting here all by itself. It's not part of a right angle triangle. I do want to point out that O to D is also a radius. O to D is also a radius and is 20 centimeters because we know radiuses in the circle are equal. So we know that that is also 20. So if I can figure out O to C, I could take that away from 20 and I would get CD. All right, so that's what we're going to do next. We're going to figure out O to C. So I have a right angle triangle. This is what it looks like away from the circle. 12 centimeters, 20 centimeters. I need to figure out what that piece is there. Okay? So this is a subtraction Pythagorean theorem. 20 squared minus 12 squared equals, we'll just call that unknown side x squared for now. So 400 minus 144 equals x squared. Can give you 30 seconds to figure that out. Okay, 400, take 144, end up with 256 equals x squared. We can see how that is definitely not the answer. So we have to square root both sides first. So square root on both sides leaves me with that unknown being 16 centimeters. Okay? So 16 centimeters. All right, if I know that that piece is 16 centimeters, and I'm trying to find CD, that equals 20 minus 16, which would be 4 centimeters deep. That would be the depth of the water. Okay? So, multi-step question. We had to first figure out OC, which was part of the right angle triangle. Then we used our knowledge of the size of the radius and subtracted that OC away to get CD. Okay? All right. That's all I have for examples. When you come to class tomorrow, you're going to get the opportunity to practice a little bit more. And let's see, we're at about 13 minutes. I'll give you a different example just so you can try an angle example. If we have a circle, and I got chord A, B, okay, and I'm going to give you a line through center, O, and I'm going to tell you that AB is bisected, and I'm going to give you the radius too. I'll put a little C in here. Can you tell me what angle BOC measures if this angle in here is 25 degrees? Okay? So I've given you angle OBC is 25 degrees. I want you to tell me what BOC is. So that angle is just up in here. Okay. Well, how do you approach this question? See what you've been given. You've been given a line through center that bisects a chord. So we got line through center, and we've got bisected chord. You read my handwriting. Okay, so line through center with a bisected chord, that means that OC is perpendicular to OP. That's that third part of the rule. So if it's perpendicular, we know then it's 90 degrees. We add our 90-degree symbol in. Now I have a triangle that I know the sum of the interior angles is 180. So 180, take 90, take 25, and I would be left with how much? Hopefully you all just shouted at your computer monitors. 65 degrees. Okay? Alright, when you come to class tomorrow, remember there's a sub in tomorrow. He's going to give you the practice questions from the textbook to try. I cannot stress enough, this is Pythagorean theorem and subtracting angles from 180. Those are your two basic skills. That's why we started the unit with them. Check out some other videos I'm going to attach that are also for chord properties if you're looking for more examples, and just shoot me an email if you have any questions. Have a good day tomorrow, guys.